Well, my public speaking value just went down dramatically because now I'm being recorded and Mike Brown's here. So that's not good for me, but that's okay. We'll muddle through it. Like I said, Staunton District Materials Engineer for VDOT. We've got a lot of 81 widings going on. If you were lucky enough to see the first presentation I did, that was on an older recycling project where we recycled a lot of the in situ material, the existing pavement. This one's a slightly different idea that I'll run into. So, you know, if you caught that presentation, some of this, but not much, will be repeated. So I'll just get right into it. And Ryan, you just stop me if I'm going over, because I can talk about FDR virtually all day. So this is the piece of equipment we're talking about, the Widening Reclaimer. And I was a couple months ago, I was actually able to see there's a new Caterpillar. Caterpillar's trying to get into this game as well. So they have a piece of machinery they're trying to sell too. So the easy things that you need to kind of be familiar with if you're thinking about setting up an FDR project, the width of the drum will, constrain what you're able to do. So if you have a 12-foot or 14-foot lane, you've got to do 2 passes. If you have anything less than 7 foot 10 inches, or it's going to come out 7 foot 10 inches. There's no smaller drum that you can slap on this thing. 20-inch max depth. We don't usually go that deep because it is somewhat hard, almost 2 feet deep, to get good compaction all the way through the material. And 8-degree max cross slope. That's on your pavement, so your super elevation. We don't have a whole lot. I'm not sure if we have any. I'm in Staunton, so we have some mountainous roads. I don't think we have any supers that are actually greater than that. One thing to remember, it's a very, very big piece of machinery. They used to, like I said, my last presentation was on a project back in 2011, have some issue crossing bridges with this thing just because of the axle loads and all that. And they've kind of figured that out now, having gone through that pain. So what I'm here to talk about are the number 10 screenings. So if you're familiar with crushing rock, central mix aggregate, all that stuff, number 10 screenings are a byproduct of any crushing at a quarry. And we have literally tons and tons and tons of this stuff. All of these pictures are from quarries along 81 in the Staunton district. And that's our intern, Trey Thompson, in there for scale. Just to give you an idea, we've got mountains and mountains. And usually at VTRC, we talk about RAP. We've got 3 million tons of RAP. We got to use this RAP. But we have probably 3 to 5 times that much material in these quarry byproducts, which a lot of people will simply call waste material. And I think I may have skipped something. I'm having a little trouble. So again, we've got tons and tons. Just those pictures, about 305,000 tons, just 9 quarries. And we have a lot more quarries than that. This was just a quick survey. If you're used to buying aggregate, $11 to $20 should make you very excited. That is a fantastic delivered price for aggregate of any kind. If you're familiar with CBR, it's a California bearing ratio. So a perfect, well-graded aggregate from California would be a CBR value of 100. Some mud that you may have stepped in on the way in, now that things are finally falling out, would be like a CBR of 1. So if you just take the unstabilized number 10s, put it in a Proctor mold, do a CBR on it, you'll get about a 65. So that's really strong material. The only issue, of course, is that it is kind of erodible. So the VTCA, the Virginia Transportation Construction Alliance, a massive organization or association of our contractors, including the quarries, have asked VDOT for years, please find a place to put this stuff. We can practically give it to you. You saw the prices. Just find a way that we can use this stuff in mass. So we started with pipe backfill. That was easy, but that's a very, very low quantity. Can't get rid of much of it. So we built a special provision to use this as embankment material. And it is great material, doesn't settle, very strong, high fee if you're into embankment design, but you do have to cover it if you're near a creek or it could be inundated, that kind of thing, because it is erodible. It's like a sand. It's like an engineered, manufactured sand.
Gravel dust, is that what we're talking about?
Yeah, it's basically dust. It's basically stone dust. Number 10 is basically the sand particles and lower. So, and you know what? Now that I'm here, I had a sample that obviously I should have brought, which is, funny because I did this presentation in Blacksburg at Tech, left my sample there. So I bought another jar, got another sample, and forgot to bring it here. So thanks for pointing that out. So we thought, okay, we'll get rid of that erodibility issue. We'll look at stabilizing this stuff. And we initially thought, it's so fine. It's got so much surface area. It's going to take so much cement. It's not going to be cost effective. But what we actually found was we only need about 3% cement by weight added to this material to get about 300 PSI. And that's what we're looking for full depth reclamation. So on these widening projects where we're widening to the inside, we don't have material there. We don't have that existing pavement or sub-base aggregate to recycle. The idea is to bring in this material, place it there after we've graded it, and then do the FDR.
When you add the cement to the mix, does that make it less erodible, I presume?
Oh, yes. And it's like a poor man's concrete at that point. Yeah. So unfortunately, like I said, there are no samples available after. Unfortunately. So I don't know how much pavement design you guys get into. I knew I'd be talking to civil engineers, so I left some of the technical stuff in there. So bear with me. This layer on our Staunton widening project, that's a design build job that's going on right now. Between exits 225 to 227 roughly, both directions. We're using a 12-inch, so 1 foot FDR layer. We represent that as a non-stabilized layer for the purposes of MEPDG. And you can probably figure out we have a lot of trucks on 81. This is very, very high traffic for any road in the country and frankly anywhere. We've got about 28% to 33% trucks. So it's a ridiculous amount. So getting a little further, and again, probably into the weeds, but we're using a resilient modulus of 80,000, which we feel like is very conservative. To give you some idea what that is, we use 80,000 for our cement treated aggregate. So that's more like a 21B that's got 8% cement in it. Our open graded base, which is pretty much a rock fill with nominal particle sizes about that big, 40,000. Your usual central mix aggregate, number 21B that you'll see for sub-base for most of our pavements is 21,000, and a plastic clay is about 11,000. So again, conservative, but way up there. High quality aggregate is how we're modeling it. The number 10s are a little finer than what we've gotten here now, but luckily we've got the VTRC, the Research Council, has done and is doing a lot of research to see, okay, what are those numbers? Are there better numbers that we can use? What should we be doing with our designs? So I don't know if you've seen this before, but the 4 criteria when we design pavements, the red lines are the maximum. So we're good with IRI or smoothness of the pavement over the design life, which is normal. Now, from the previous project, we sent a lot of that material down to Auburn, to the NCAT test track. And it's a very large oval where they use weighted trucks and run them constantly for 2 years and then stop for a year to do their testing and instrumentation. So this is basically what we've got, that little dot there. I think I might have a pointer. I'm not sure. Should have asked. Don't want to push a bunch of buttons. Don't know what they might do. So the little orange is what we've got for our similar material down at NCAT. So rideability is not an issue. The one that we did in 2011 is one of our smoothest pavements on 81 right now. So the bottom-up cracking we are very concerned about. Normally, you'd see our results would be a lot closer to that line. We're trying to optimize. but for various different reasons, this total rut depth is what really controls it. And you see from the NCAT stuff, we're way below this. We're getting much better performance than we're actually putting in our pavement design software. So we're in thermal cracking. We don't have an issue with that in Virginia, so we don't really look at that one. But you can see we're getting a lot of good performance. So having done one pavement design, we did a whole bunch of other ones. We did our typical, which is usually an open graded base, 21B, base mix, intermediate surface. Did concrete. Let's see. We did FDR with cold replace, cold pavement recycling. We did CRCP, continuously reinforced concrete pavement with FDR. We did a lot of different things to do this life cycle cost analysis. And we used our current bid prices from all the VDOT jobs, all that good stuff. All that just to say this is way cheaper. FDR is about 18% below our typical design. It's about 28% below what you would get currently with a concrete pavement design to get the same performance. So a lot of value available there. So for the projects that we have currently underway in Staunton District, as I said, Staunton's ongoing. Strasburg should start in the next couple months. Weir's Cave's been awarded. We had the pre-con for that, so we know those numbers. Harrisonburg, that's an estimate. That is probably going to go out to bid in September of this year. Much bigger project. That's about 12 lane miles. Lexington and Winchester should be the next couple, so those are based on preliminary engineering, preliminary pavement designs. But you can see we're looking at about $26 million just in current savings. Never mind the life cycle cost. Same thing exactly, but in terms of tons of number 10. So these are tons of virgin aggregate that we're not using. We're using a quarry byproduct and we're recycling it. So I know you can do math, but that's about almost 17,000 20-ton trucks. So think of the amount of crushing, the amount of sizing, all that good stuff, the amount of diesel to deliver these things and put them down. It's a very, very big, not only cost savings for the taxpayer in terms of initial cost and life cycle, but it's also a huge environmental cost savings. So we built a special provision that we used back in 2011, changed that up a little bit so we could use it on design build jobs like in Staunton. Basically, they're pretty much the same. We included some language so the VTRC here could add some instrumentation during construction so we can get those numbers. One issue I think I got into the last presentation. I don't think I get into it here. Is one of the issues with our NCAT sections is we went very conservative with depths, and we had one section that just would not break. To get that. To get the numbers we need for pavement design, you have to break the sample. You have to break the test section. And one of them just would not break. So we quit paying for that. One thing that we noticed, the number 10 screenings, especially from one quarry, very, very homogeneous. You saw those pictures in the very beginning. They're all the same color. They're all the same size. They're just incredibly homogeneous. I'll show you a gradation test result here in a minute. You don't have, unlike existing pavement, when you're working on the existing pavement or in situ materials, the contractor has to get the award, has to be executed, then they can go out to the project and do the sample to get their job mix formula from the laboratory. With the number 10s, they're out there. You can go to the nearest quarry, wherever we are from here. Sorry, I'm in Staunton District, so I'm thinking there. You can go to Staunton Lime. You can buy as many number 10s as you want right now. I put some in my chicken coop area. So, yeah, they're happy to sell those to you. So just some numbers from the Staunton Widening. Stabilizing agent rate was 4% from their lab testing. Optimum water content, 7.7. Max theoretical density, 135. So you can see where that kind of shakes out. So this is the gradation curve, and I'll go through this just a little bit, just to show how homogeneous this is. There's the other one, and there's the other one. So it doesn't shift hardly at all. Again, there may be some difference between quarries, but just not a lot. Come on now. So very homogeneous material, unlike if you're doing an existing pavement, this half mile is made out of this stuff, this half mile is made out of that stuff. The subgrade changes. We stopped using this base, we're using that base. The aggregate's different. This stuff, since you're bringing it in, you're importing it, putting it down, super homogeneous. So the orange, this is our compressive strength versus cement percent by weight. So like I said, we took some sample, maybe 2 years ago, added 3% and 5% by weight. The lines obviously are minimum maximum, so we want a certain amount of strength. Again, so it's not erodible, so we're getting the strength. We can use that 80,000 PSI resilient modulus, but we don't want to go above that. Anything above that we feel like is going to crack, kind of like I'm kind of an asphalt guy, so luckily the concrete industry isn't here, but concrete cracks, anything you put on top of that will crack, and the cracks mitigate up and never go away. So we're trying to keep that from happening. So we can get good strength, but we don't want to go above about 450 PSI to mitigate that cracking. So we felt like 3% was going to work. Initially, Haley and Aldrich did some testing there in the green and thought maybe 4.5% would work. Then everybody changed from type 1 and type 2 cement to type 1L. So we went back to the drawing board, had them resample, and these are done really quickly. You do a proctor, you add some cement, you cure it, you break it. Very simple. Does take a little bit of time for the cure, but what we found out was the blue, 4% would work. And then getting your maximum theoretical density and your optimum moisture targets for the field, super easy. Do a proctor with that percentage that you've already, you probably already have this done. But if you picked 4.25%, something like that, you have to go back and just do one proctor. It takes 2 days. So you've got your maximum dry density and your optimal moisture content. Those are your targets for QC and QA in the field. We don't mess with roller patterns, control strips, all that stuff. This slide is in here, I'll be honest, to pick on the consultant on the design build job because they complained about their QC plan approval taking too long. So I have a little timeline here for my area construction engineer. This is how fast the turnaround times are, but also to point out the importance of the quality control plan. I'll get into exactly what those requirements are. Especially on a design build job, you want to have a good quality control plan so they understand, so the sub understands. A lot of the issues that we worked through here were the prime not communicating with the sub, just not asking the guys. You'll see some of those issues when we get into it, but normal things that you see in a quality control plan. Are you technician certified? Is your laboratory qualified? What does your QC documentation look like? What are you actually going to inspect when you're out there? Corrective actions and contingency plan, hugely important. You don't want to be in the middle of 81 in the middle of the night, something fails. Okay, what do we do? You don't want to have a meeting the next morning to discuss it. You want to know right then how to fix it. And again, your density targets, just so they understand that, because consultants will sometimes, and now that I say that, I know I'm in a room of consultants, contractors will sometimes slip in density targets or say, this is the answer. So that's not what your lab results said. So anyway, another thing, because it's a relatively new innovation, we haven't done a whole lot of FDR. We're getting more and more experience, and we've changed our spec to show some of our lessons learned and what contractors didn't like about bidding and all that good stuff. But the test section is very, very important. We give you about 1,000, 2,000 feet, depending on the width and all that good stuff, to use those technicians, those guys, that equipment, these materials. Show me that you can do it. So we did that, had our prep meeting, did a trial section. Weather was good, didn't rain, wasn't very windy. Temperature was good. Got our test data, met our target for cement content. That's pretty easy. You'll see the test here in a minute. Water content was a little low. We don't want to be too wet. We've got to be within our range for optimum water content so that we'll get density, so they can get density. but it's also a cementitious material, so we kind of like to see them on the top end of that. Don't want to see it too dry, because then we're not going to get that early strength gain. And density was a little bit low on that one, but it was within the 97% of max theoretical density that we require. So the started production, the design builder wanted to use 2 different types of cement in case one broke down, which is a great idea, but we didn't have a test section for that. They switched on that first day of production without telling anybody. Sometimes happens, but we, again, treated it like a test section, got the testing that we needed, and as it turns out, you see we improved a little bit on some of our data. For the second one, we actually got 100.1% density. So we said, okay, what's happened has happened. Your test section is approved. You can move on now.
Don't do it again.
Please don't do that again, which is, it's a terrible precedent because it worked, right? So this is basically what it looks like. We've got our grade here. Got the existing 2 lanes and shoulder of 81. They could have used a stone box. It would have been nice, and you'll kind of see why. But, means and methods, not too worried about. These are the number 10s that they're bringing in from Staunton line. It's kind of funny because the sub for this was slurry pavers. You can put the cement down in a slurry so that it won't be quite so dusty. But even slurry pavers likes to do it this way for whatever reason. Simple tarp test to determine our application rate. Put the tarp down, send the truck over it, drop the cement, weigh it up, see what the number is. Did we get our minimum? So this is the FDR in process. So you have a water truck and the FDR machine. The number 10s and the cement are already down, and that thing is just a big mixer. It's about 800 and something, I forget, horsepower. It's pretty fantastic if you like big toys. So, like I said, we were probably up in the 70s. It wasn't terribly warm, but they were adding some water to the top. Again, to keep the evaporation down, not a problem, but don't think that water is going to somehow get to the bottom of the layer and help your density. Well, I press it light, I press it hard. Okay, so then after we've mixed it, initial rolling with the sheep's foot roller, then the grading with the motor grader, and you can see right there, we're moving a lot of material around for some reason. Get to that in a second, but just to point that out. So we're going to get it to grade with the motor grader and then roll it with the smooth drum roller. There is a paver laid FDR now that uses slightly different equipment, mixes it up, drops it into a paver, got a screed on the back of the paver. That is really nice because it's a lot wider. You can do a full lane width at a time. But not everybody has that equipment yet. It's relatively new. So this is a picture of the finished product, just the number 10 FDR. You can see we allowed them to drive on it. They'll have to clean that up a little bit before they pave it. But this is, again, very strong stuff. You can put loaded trucks on there. You got to watch your turning movements, things like that. Try not to get it too dirty. So I mentioned, and I won't go into too much detail, but we're trying to get the VTRC out here, put in some pressure cells, strain gauges, temperature probes, water probes. They have a plan for that. Just trying to find a good section. It's a little too cold right now. We haven't been doing a lot of this since October. But we're going to get all the instrumentation so we can really test it in situ, get some good information. So this is a picture of Chimney Rock in North Carolina. Of course, we had that big hurricane. That's after and before the exact same spot, supposedly. So, yeah, a lot of water. We didn't get quite this much, thank goodness. But obviously that set their schedule back a little bit. Right now, the project's back on schedule. No claims, anything weird like that. No big arguments about our special provision or FDR or anything. Some of the lessons learned, again, very, very consistent compared to even wrap from a wrap stockpile from your asphalt plant, and especially in situ material. Communication, as always, is key, but definitely between, if they're going to have a sub, there are a lot of subs. Slurry pavers is one, I can't remember everybody's name, that do FDR, and that's what they do. So you don't see them being the prime too often. but getting those guys to talk to each other, especially on design build, and then what we call fluff. And I'll get into that real quick. So again, we're moving all this material. You see the windrows on the side. We've stabilized that with cement, all that good stuff. But and this is in our specifications. I had a guy, actually one of the foremen, when we came out and talked to them about this, say, man, I wish somebody would have told me. I said, well, it was in the pre-con meeting. We mentioned it in the spec. We talked about it here. You came to the training. We talked about it. So fifth time's a charm. But fluff is basically you're adding mass, you're adding water and cement to something. It's going to fluff. It's going to take up more volume. You're not going to have necessarily the same density if you had an existing pavement that's I don't know what 160 pounds per cubic foot, and your end result's 135 pounds per cubic foot. You're going to increase the volume there, so you need to take that into account. You don't have to. You can do what they did. It's way more fun. They took off I don't know how many tons of it, and they're using it for pipe backfill. But it's kind of a waste, and there are some other issues too. So you anticipate that fluff. Instead of 12 inches, maybe you put 11 inches of screenings, then the cement and the FDR, and hopefully you end up right there at grade. You barely have to use that motor grader. You're right on grade. Compact it. There you go. No problems. Except for my button. If you don't, then obviously it's going to be higher than grade. You're going to take that material off. So if that's your final grade, it's got to go somewhere. Now, you've compacted this material. Like I said, the further down in the layer you get, obviously, the same amount of compaction, the less compaction you get at the bottom. So if you've added 2 inches to that, you're getting even less compaction at the bottom of your layer, which is not what we're paying you for. In addition, you've put the right amount of cement because we did the tarp test. We know we've got 4% cement by weight, but you've added it to more material, mixed it up, and now you've taken 2 inches of that material off. So I know some of my cement is gone. So I know I'm not going to get the strength that we required. So that's another big thing. That's not what we're paying you for. We're paying you for 4% cement of the final 12 inches of FDR. And this is what you can get. You may not get that machine going all the, because the sub comes out there, the cement's down, the number 10s are down. They're just out there to do 12 inches of FDR. So if you're 2 inches high and they do 12 inches of FDR and then you scalp off 2 inches after they've left, then you don't have enough FDR. So we've got some number 10s there at the bottom that had a little. We used the phenolphthalein. You can see a little bit under that shadow. It's purple, but it hasn't set up. So A, the density, and B, the cement is not there. So being VDOT, of course, we have to punish the wrongdoers. So we did a bunch of cores. We made them do a bunch of cores. Hey, what we saw here, this is actually a trench for our under drain to go in on the side. So luckily, our inspector saw it and said, hey, what do you think of this? I said, hey, I don't know. Let's make them test it. So we did tests in the shoulder. We did tests in the main line, everywhere. And we luckily, somehow, we did get at least 12 inches depth of real FDR. The main line was okay. It's a full width shoulder. It's a 12-foot shoulder. So it's not like it's just a 2 or 3 foot shoulder where you're not as worried. Thinking maybe some of those areas didn't get enough density, didn't get enough time to harden.
Sorry, what was it? Did not get hardened what?
Yeah. The bottom at the under drain may not have hardened as well. And this is on the outside edge of the shoulder.
Because the cement didn't get indoctrinated, it didn't get...
Probably didn't get mixed as well on the very outside edge, and because they were 2 inches high, probably didn't get mixed as well with the rest of it. So for whatever reason, it didn't harden over the 7 days it should have. But again, we did the cores to verify main line's good, most of the shoulder's good. It's just that outside edge. So they were concerned. The reason they did the FDR first and then the UD, they didn't want to put the UD in and have that equipment on the top of the UD trench and possibly crush their pipe. So they did this instead, and now what we're finding is we're not going to do that again. We're going to put the UD in, because what you do, even if your FDR is set up, you get something like this. When you actually trench in, you get these cracks because it's unsupported now, and you've got relatively large pieces of equipment banging on it. This is their trencher. It's pretty old. They make a lot smaller, lighter ones. And then to put the backfill, you're putting the truck right on that unsupported edge. So we've told them, look, that's it. We're going to put the UD in first, then the FDR, and we're going to not have this problem in the future. Just some of the things you learn dealing with contractors. Future projects, I mentioned Staunton District, 46.5 lane miles, not counting the shoulders for all of these. Staunton ongoing, Strasburg basically ongoing. That one's only southbound. You see how long they are. We're talking about miles. So we've got 324 miles of interstate in each direction. Plenty of opportunity for using this. Haven't really convinced Bristol and Salem District that this is the way to go. Harrisonburg, I think that add date's probably right, September of this year. And then in the future, Lexington and Winchester sections. The Winchester section has actually gotten bigger than that. That may be, and it may be design build as well. So it may be earlier, it may be later. But as you can see, a lot of opportunity for using this innovative technique. And just the conclusions. Number 10, screenings can be easily used for widening projects where you don't have that. And I should also shout out to Research Council, Brian Diefendorfer. After we did the 81 recycling project, he stole my idea, but added to it when we widened 64, I think phase 2 and phase 3. Again, it was a widening. They didn't have material, so they used crushed concrete. So they recycled crushed concrete and did their FDR. We don't have that much in the valley. We're not as urban and don't have as much of the recycled material. So that's why we decided with number 10. So we stole that idea from him to use number 10s instead of crushed concrete. So anyway, even though it's a widening project, you can still recycle. The costs, obviously, both initial costs that the taxpayers like and the life cycle costs that the engineers like, plus the environmental division. It's a triple win. And it's very resilient based on the NCAT study and all that good stuff. We know it's probably a perpetual pavement. We'll never have to go back in and do anything to the subsurface. We'll just have to mill off the top surface. That has to be replaced anyway. And I've left this in here. Doesn't show all the roads, but you can literally use this on any of these roads. And we paid a lot for those roads. You and I paid a lot for those roads. Instead of milling everything up, letting somebody else have it, the idea is to reuse it. It's a massive trillions of dollars worth of assets that we have, and we're trying to keep it that way. So that's all I had. Any questions?
Yeah.